Hello friends, how are you? In yesterday class we discussed about two types of chemical reaction on the basis of bond formation and bond breaking, and in that type of classification the chemical reactions was classified into four categories. First one is addition reaction, second one is displacement decomposition reaction, third one is displacement reaction, and fourth one was double displacement reaction. And in today's class we will discuss about more types of chemical reactions. On the basis of the rate of reaction, the chemical reactions are classified into fast and slow reaction, and that is our first topic, that is slow and fast reaction. On the basis of the rate of reaction, there are two types. One is fast reaction and one is slow reaction. First is fast and second one is slow reaction. If we consider the first, that is fast reaction. What is the fast reaction? Those reactions whose rate of reaction is very high. Whose rate of reaction is very high. That means they take very short time to complete. Those reactions which take very short time to complete, very short time to complete are known as fast reaction. These are known as fast reaction. Those reactions which takes very short time to complete is known as fast reaction. The ionic reactions, like the neutralization reaction between the strong acid and strong base, like the neutralization reaction between strong acid and strong base, come in the category of fast reaction. They come in the category of fast reactions. Okay, these reaction, that means neutralization reaction, completed into 10 to power minus 10 second. They complete into 10 to power minus 10 second. Okay, the example, if we consider the example, then we can say that NaOH plus HCl, NaOH plus HCl equals to NaCl plus H2O, equals to NaCl plus H2O, comes in the category of fast reaction. Comes in the category of fast reaction. Here, if we consider its mechanism, if you remember that in NaOH and HCl, if we consider this mechanism, then here NaOH, that is Na plus and OH negative, combine with HCl. HCl means Ha plus and Cl negative. They combine and make NaCl and H2. The positive part, that is Na plus, combine with Cl negative and make NaCl. The H plus and OH negative, they combine and make NaOH. Okay, so that come in the category of ionic reaction, which is come in the category of fast reaction. Some double displacement reactions, some double displacement reactions also comes in this category, like the silver nitrate AgNO3 combine with HCl and make silver chloride and HNO3. That is also ionic reaction, which comes in the category of fast reaction. The photosynthesis is also a fast reaction. Photosynthesis, which is a very important reaction in our nature. You know that photosynthesis is the reaction which proceed in plants to make their food. This reaction is also come in the category of fast reaction. That is also fast reaction because its half-life period is only 10 to power minus 12 second. 10 to power minus 12 second. That is its half-life period. Okay, now the questions comes in our mind, that is what is half-life time. Yeah, what is half-life period? The time taken to convert half of the reactant into product, half of the reactant into product, is known as its half-life period or half-life time. Suppose if we take 1 gram of any substance, then the time taken to convert its zero point 0.5 gram into product is known as its half-life time. Okay, So that is examples of fast reaction. Now slow reaction, it is just opposite to the fast reaction. In the fast reaction, the rate of reaction is very fast or very high. Here the rate of reaction is very less. Fast reactions completed in very short time, these reaction will take longer time. Okay, so we can define that those reaction whose rate is very less and take longer time, which may be hour, days, month or years to complete, are called slow reaction. These are called slow reactions. Okay, if we consider this example, then rusting of iron. First example is rusting of iron, in which iron react with the oxygen and water and make Fe2O3 and chemically bonded H2O. That is known as rust. In some of the books, in place of the 6, X is used, which is a number, which may be 1 2 3 4 5 6 7 8, anything. If we consider in that manner, then we write this reaction is Fe2O3 Fe plus O2 equals to Fe2O3 dot XH2O. Okay. Second is thermal decomposition of potassium chlorate. When potassium chlorate is heated, it dissociates into potassium chloride and release oxygen gas. It takes longer time, so that's come in the category of slow reaction. And third one is esterification, the formation of ester. When acetic acid react with ethanol in the presence of the acid, when they are heated, they forms ester. Okay, here that parts HOH combine and make H2O, and the remaining parts join and make ester. If you remember that ester, that means those organic substances in which C double bond OO and both sides carbon chains are present is known as ester. If we consider its a chemical name, while it is not in our syllabus, but let me discuss, that is ethyl acetate. It is called ethyl acetate or ethyl ethanoate. Ethyl acetate or why it is called ethyl acetate? Because it is also called ethyl alcohol, and it is called acetic acid, so the name is ethyl acetate. If we consider its IUPAC name, then it is called it is called ethanoic acid, and it is ethanol, so it is also called ethyl althanoate. Okay, now after that, let me move to the next classification, which is reversible and irreversible reaction. On the basis of the reversibility, there is two types. One is reversible and one is irreversible. If we consider the definition, then we can say that reversible react. Let first we discuss about the irreversible reactions. Those reactions which proceed only in one direction, and that is reactant to product, are called irreversible reactions. Those reactions which proceed only in one direction, that is reactant to product, are called irreversible reactions. In these reactions, the concentration of reactant continuously decreases and the concentration of product is continuously increased. As the reaction proceed, the concentration of reactant decrease because it is converting to product, and the concentration of product continuously increase. At the end of the reaction, the concentration of reactant becomes zero and the concentration of product becomes maximum. If we consider its example, then the burning of carbon, that is C plus O2 equals to CO2, the burning of methane CH4 to O2, that come in the category of irreversible reactions. Now, reversible reactions, those reactions which proceed in both direction, that means reactant to product or product to reactant. In the starting, the reactant is maximum, and when it convert into product, some amount of product again can start to convert into reactant. So that means these reactions proceed in both directions, are called reversible reactions. In these reactions, the concentration of reactant never be zero, cannot be zero, because as the reaction proceed, the product start to convert in reactant again. That means in these reaction, the concentration of reactant never be zero. And if it is never be zero, then we can say that these reactions never complete, because the completion of a reaction is the zero concentration of reactant, and here the concentration of reactant cannot be zero, so that is these reactions never be complete. We can say that these reaction is never complete. If we consider its example, then we can consider that N2 plus 3H2, N2 plus 3H2 equals to 2NH, the reaction of formation of ammonia. Here starting, the nitrogen and hydrogen start to combine and make ammonia, and after attaining the equilibrium, the ammonia again start to break into nitrogen and hydrogen. That means the reaction proceed in forward and backward. This is called forward, that is called forward, and that is called backward. So the reaction proceed in forward and backward both directions. Similarly, if we consider the second example, that is reaction of water with carbonic acid. Here when they react combine, they form H3O positive, H3O positive. What is called? It is called hydronium ion. So they form hydronium ion and carbonate, HCO3 negative, hydrogen carbonate ion. Okay. Now, next example is transportation of oxygen and carbon dioxide by hemoglobin is also example of reversible reaction. In the lungs, the hemoglobin take oxygen, combine with oxygen, and take towards our body cells, tissues, and from the cells it release the oxygen and take carbon dioxide, Here this cycle is proceed. So if that is not reversible reaction, then hemoglobin is going to permanently attach with the either oxygen or either carbon dioxide. Then how the transportation performed in our body? So in this, the transportation, hemoglobin time to time combined with that. Okay, so that's come in the category of reversible reactions. Now next topic is oxidation and reduction. It is very important for our exam. It is very important for our exam. And let me clear you one thing, that it is very typical topic. Before starting this, one thing let me clear you, that oxidation and reduction are just opposite to each other. They are just opposite to each other, and they are half reactions. And the incomplete reaction, both oxidation and reduction takes place together. To understand it, let me consider one example so that it made it clear to you, that according to the first definition, if we consider that addition of oxygen is known as oxidation, while the removal of oxygen is known as reduction. If someone take oxygen, then it is sure that some other releases the oxygen. If someone gain, then some other release or lose. That means if one is oxidized, then other is reduced. One is oxidized, then other is reduced. So these are half reactions. Clear? Suppose that I am that is oxygen. That is oxygen. It is attached with that. It is attached with that. And that is other substance. If this oxygen attach with that, then addition of oxygen, so it is oxidation, but here it loses the oxygen, or release, that is removal. So when it removed, that means it is reduced, then it is added, that is oxidized. Got it? So oxidation reduction takes place together. One thing let me clear, because if that point is not cleared in your mind, then there are lots of controversial points, that is lots of controversy will create in your mind. Okay, so clear? Now let me start to discuss about it. First, there are various type of there are various bases to explain the chemical oxidation and reduction. First is on the basis of oxygen. Second is on the basis of hydrogen. Third one is on the basis of electronegative species. Fourth one is on the basis of electropositive. Fifth one is on the basis of electron, and sixth one is on the basis of oxidation number. But oxidation number is not in our syllabus. But we will discuss a little bit about that. Now, firstly, on the basis of oxygen, according to which the addition of oxygen in any substance, is known as oxidation, while the removal of oxygen from a substance is known as reduction. Addition of oxygen, oxidation; removal of oxygen is known as reduction. If we consider its example, then here magnesium combine with oxygen and make magnesium oxide, MgO. Here oxygen is added in magnesium. So we can say that magnesium oxidized into magnesium oxide, MgO. Similarly, in this second example, sulfur react with oxygen and make sulfur dioxide. Here and here oxygen is added, so sulfur is oxidized. Got it? If we consider the example of reduction, then the first one is potassium chlorate on heating decompose into 2Kc potassium chloride KCl and release oxygen gas. Here oxygen was attached, but here oxygen is removed, and you know that removal of oxygen is known as reduction. So that is 2KClO3 potassium chlorate reduced in potassium chloride. Similarly, when magnesium oxide is heated, it releases oxygen. So we can say that magnesium oxide is reduced in magnesium. Okay. Now, second basis of our oxidation reduction is on the basis of hydrogen. According to this concept, the addition of hydrogen is known as oxidation, while the the addition of hydrogen is known as reduction, while the removal of hydrogen is known as oxidation. The removal of hydrogen is oxidation, and the addition of hydrogen is known as reduction. Clear? Let me consider the example. In the first example, ethanol convert into ethanal, that is ethanal. Here and here there is two hydrogen atoms are removed, or hydrogen gas is removed, so it is example of oxidation. Similarly, H2S when react with the oxygen, it gives H2O, water and sulfur. Here and here hydrogen is attached, but here hydrogen is removed, so the removal of hydrogen that is oxidation. So we can say that hydrogen sulfide is oxidized into sulfur. If we consider the examples of the reduction, then we can consider the first example here. H2 react with Cl2 and make 2HCl. If I consider this chlorine and that chlorine, then here hydrogen is added in chlorine, so I can say that chlorine is reduced in hydrochloric acid HCl. Similarly, if I consider the example of hydrogenation of ethene, that is ethene, then ethane is formed. CH3 single bond CH3, it is known as ethene. Here hydrogen is added. So we can say that ethene is reduced in ethene. Got it? Now, on the basis of electronegative species, the in starting the chemical reactions are explained on the basis of oxygen and hydrogen, but later on it is found that on the basis of oxygen and hydrogen, these bases are not sufficient. That's why some other definitions were developed, in which electronegative species is used as base. Electronegative species, that means which have generally negative charge. Those elements or those species which generally have negative charge, or when they the behavior of that is making anions, are comes in this category. They are similar with oxygen. Okay, because oxygen also has electronegative nature, because oxygen form O negative two ion, as we discussed in class 9. Okay, now according to this concept, addition of electronegative elements is oxidation, while the removal of electronegative element from a substance is called reduction. The addition of electronegative element, like the addition of oxygen, is known as oxidation, while the removal of that substance, that is electronegative substance, from its electronegative component, species or element, is known as reduction. If we consider its example, then the first example, let me discuss about it. Magnesium combine with chlorine and make magnesium chloride. Here generally Cl have tendency to make chloride and Cl negative, that is electronegative. Here electronegative element is added in magnesium, so it is oxidized. Similarly, if we consider the next example, the zinc react with bromine and make zinc bromide. Bromine also have tendency to make anion, that is electronegative nature, so it is added into zinc, so we can say that zinc is oxidized in zinc bromide. Here reduction, the removal, if we consider the first example, then FeCl3, and after reaction it is formed FeCl2, so there is a removal of Cl negative, that's why it is reduction. That means we can say that FeCl3 reduced into FeCl2. Similarly, silicon tetrachloride react with sodium, then it forms sodium chloride and silicon. Here and here, that is chlorine, but here not, that means chloride is removed, Cl negative is removed, so we can say that silicon tetrachloride is reduced. Got it? Now our next basis of that is on the basis of electropositive element. Electropositive element shows similar behavior like the hydrogen. That means we can say that on the basis of the hydrogen, the similar, sorry, it is similar with the hydrogen. Like the hydrogen is added in reduction, so we use here electropositive part is added in reduction. In that definition, hydrogen's removal is oxidation. Here, the electropositive part removal is oxidation. So we can say that on this concept, removal of electropositive element from a substance is oxidation, while the addition of electropositive substance is known as reduction. Yeah. Now let me consider the first example. Potassium chloride react with the chlorine. Here, and make 2 KCl plus iodine. Here, this iodine and this iodine. Here the potassium, which is electropositive, is added, was added, but here it is removed. So we can say that potassium iodide is oxidized into iodine. Got it? Here in second example, H2S react with Cl2. This hydrogen combined with chlorine and make HCl and sulfur released. This sulfur and this sulfur, there hydrogen is added, which is electropositive part. Electropositive because H plus, normally H plus ion formed by hydrogen. So hydrogen, that is electropositive part, is removed. Is removed. That why we can say that H2S is oxidized. If we consider the example of reduction, then Mg plus Cl2 equals to MgCl2. Here chlorine and that chlorine, magnesium is added, which is positive. So it is, we can say that chlorine Cl2 reduced in MgCl2. Similarly, zinc react with iodine and forms zinc iodide. Here and here, iodine, the positive zinc is added, so we can say that iodine is reduced in zinc iodide. Now the now one thing, because these are too much complex things, too much mixing. So let we consider one thing again. Here I use this reaction in oxidation, but here I am using this as reduction. Now it's confusing? No. Here we consider is as oxidation with reference to magnesium, but here we are considering it as reduction with reference to chlorine. If I consider this reaction with the magnesium, then it again come in the category of oxidation, because in the starting of that topic I cleared one thing, that both oxidation and reduction takes place together. Here we are just considering half of reactions. That's why when I considered this reaction with the magnesium, about the magnesium, then it was oxidation, but when I consider the second half, that is chlorine, then it come in the category of reduction. Got it? Clear? About the fifth and sixth concepts we will discuss in next class. Hope you like it and understand it. One thing let me clear you, that in this week or in next week there will be your test. Okay, thank you.